Good morning, my dear students. Today, I'm going to show you some sample problems on resistors in series and in parallel. Sample problem number 1, simplify the circuit. So in this circuit, we have 4 resistors, R1, R2, R3, and R4. The first thing that you should notice is that R2 and R3 are in parallel, and these two branches is in series with R1 and R4. So when the problem states simplify the circuit, that's one way of saying that you need to get the total resistance of the circuit. So what can I do to sort of make it easier for me to solve for the total resistance? So I guess the first step is to get the equivalent resistance of these two parallel resistors, right? In that way, pag nakuha ko na yung equivalent resistance, it would be in series with R1 and R4, the single equivalent resistance, and it would be easier for me to solve it since I just have to add to get the total resistance. Okay, so my formula when solving for parallel connections is this. So instead of R total, I use R equivalent. That's just the same thing. Reciprocal of R equivalent is equivalent to the reciprocal of R1. It should be R2 and R3, I guess. R2 and R3. So the values of R2 and R3 is 4 and 4. So I put this in the denominator, and 1/4 plus 1/4 is 0.5 over 1 ohms. That's the unit for resistance. So this is not yet my final answer since I need to reciprocate this. So that's going to be 1 over zero point 0.5 ohms, and that's equivalent to 2 ohms. So if I rewrite the circuit, this single equivalent resistor for the two parallel resistors from a while ago, it they look like they would be in series, R1 with R1 and R4. So I just need to add 2 plus 2, that's 4 plus 6, that's 10. So the total resistance of those four resistors is 10 ohms. Okay, so here we have the problem in words here, and but the circuit is also provided. Sometimes it's only going to be a word problem and you have to correctly draw the circuit diagram. So let's first read the problem. The circuit has 120 ohm resistor in series with two parallel branches. So these are the two parallel branches. The first branch has 240 ohm resistor, so that's R2 here, and the other branch has two 180 ohms. So that's R3 and R4 here. They are both rated 180 ohms. We need to simplify the circuit or calculate the total resistance of the circuit. Okay, so what do you think is the first thing that we should do so that we can simplify this circuit? Well, we can take a look at branch number 2 here with R3 and R4, and we should take note that they are in series. So we can replace this with a single resistor by just adding 180 and 180. So if you replace it with a single resistor, that the value of that resistor should be 360 ohm. Okay, so this is now my new R3. Now I'm only dealing with 3 resistors instead of 4. We notice that R2 and R3 here are in parallel with each other. So I need to use my formula for solving parallel circuits, parallel resistors, and this is this way. So I would put 240 and 360 in the denominators here. And if I do the calculations, it would be 1 over 144 ohms, not yet the final answer. We need to reciprocate it to get the total resistance, and the answer would be 144 ohms. Okay, so we replace the parallel resistors with a single one with a rating of 144 ohms, and now it is in series with the first resistor R1 120 ohms. So the total resistance would be 120 plus 144. That's 264 ohms. Okay, sample problem number 3. Sometimes it's a bit more complicated because this time you are going to design a circuit. And what is given is the total resistance that you should be able to come up with. You need to achieve a total resistance of 60 ohms if you are only allowed to use two types of resistors. One is it should have a rating of 40 ohms and the other is 120 ohms. Propose at least one way to connect these resistors to achieve the total desired resistance, which again is 60 ohms, and calculate the total resistance of your proposed configuration, maybe just to check if it's really 60 ohms. It doesn't mention that we only need to use two resistors, right? So we are not limited with the quantity, just with the value of the resistances. So what I want to say, what that means is you can maybe use three 40 ohms or four 120 ohms resistor, just that it should be, or your configuration should have a total resistance of 60 ohms. Now, the first thing that we should realize is if we put these two in series, the resistances would add up, right? So 40 plus 120, that's going to be 160 already. So that's already beyond our target of 60 ohms. So I would say that our best option would be to put them in parallel, right? Because in parallel, your resistances, the total resistance decreases. So let's first just make first trial, just to check what happens if we put 40 and 120 ohms in parallel. So this is my circuit right here. This is my formula. I put the values. It's going to be 1 over 30. I still need to reciprocate. So the total resistance is already 30 ohms if I have 140 ohms and another 120 ohms resistors in parallel. But remember, I need to have 60 ohms. That's already half, right? So I guess we are on the right track. We are on to something. So I guess if I just double, right? Since this is already 30 ohms and I need to hit 60, if I just double the amount of resistors that are present. So that's why in my trial true, I put in here another 40 ohms that is in series with R1 and another 120 that is in series with R3 here. So if I add this up, that's going to be 80 ohms, right? Because they are in series, and the other side, other branch, 240. So what would happen if I did that? So putting in the values, okay. So this is one way to get 60 ohms. If I have two branches, a parallel connection, the first branch having two 40 ohms in series and the other two 120 ohms in series. For your homework, try to get another configuration, leading you to have a total resistance of 60 ohms. Good luck.